In this class, let us discuss hash set class. So in the previous class, we were talking about linked list, array list classes. And now here, let us see hash set class. Hash set extends abstract set class and implements the set interface. Hash set has three constructors: hash set, hash set collection C, hash set the initial capacity. So it creates collection that uses hash table for storage. Hash table stores information by using mechanism called hashing. In hashing, the informational content of a key is used to determine unique value called its hash code. The hash code is then used as the index at which the data associated with the key is stored. Hash set does not maintain any order of elements. Hash set contains only unique elements. Let us see the example for HashSet class. In this example, we are creating HashSet that stores string values. Since HashSet does not store duplicate elements, we try to add duplicate elements, but the output contains only unique elements. So the example code is import java.util.star class demo public static void main string arguments HashSet string hs equal to new HashSet string hs.add b, hs.add a, hs.add d, hs.add e, hs.add c, hs.add a, system.out.println hs. So when the above program is executed, the output is within brackets a, b, c, d, e. Though we have added duplicate elements at the output, they will not be appeared. Now another class, which is tree set class, it extends abstract set class and implements the uh, navigable set interface. It stores the elements in ascending order. It uses a tree structure to store elements. It contains unique elements only like has set. Its access and retrieval times are quite fast. It has four constructors. Tree set, it creates an empty tree set that will be storing in ascending order according to the natural order of the tree set. Tree set collection C, it creates a new tree set that contains the elements of the collection C. Tree set comparator, it creates an empty tree set that will be stored according to given comparator. Tree set sorted set SS, it creates a tree set that contains in the sorted order. Now the example for tree set class, let's take an example to create tree set that contains duplicate elements, but you can notice that it prints unique elements. That means it does not allow duplicate elements. Import java.util class demo public static void main string arguments tree set string al new tree set string al.add Ravi, al.add Vijay, al.add Ravi, al.add Ajay, iterator itr equal to al.iterator, while iterator.hash next system.out.println iterator.next. So when the above program is executed, output is Ajay, Ravi, Vijay. Then another class is priority queue class. It extends abstract queue class. The priority queue class provides the facility of using queue. It does not order the elements in FIFO manner, first in, first out manner. Priority queue has 6 constructors. In all cases, the capacity grows automatically as elements are added. Priority queue, this constructor creates an empty queue. By default, its starting capacity is 11. Priority queue in initial capacity. This constructor creates a queue that has the specified initial capacity. Priority queue initial capacity comparator this constructor creates a queue with the specified capacity and comparator. The last three constructors create queues that are initialized with elements of collection passed in C. Priority queue collection C priority queue C, priority queue sorted set C. So if no comparator is specified when a priority queue is constructed, then the default comparator for the type of data stored in the queue is used. The default comparator will order the queue in ascending order. Thus, the head of the queue will be the smallest value. However, by providing a custom comparator, you can specify a different ordering scheme. Let us see the example code um, to create a priority queue that store and remove elements. Import java.util.star class demo public static void main string arguments priority queue string queue equal to new priority queue string queue dot add v queue dot add love queue dot add study queue dot add tonight system dot out dot println at head of the queue plus queue dot element system dot out dot println at head of the queue plus queue dot peak system dot out dot println iterating the queue elements iterator itr equal to q dot iterator while itr dot has next system dot out dot println iterator dot next q dot remove q dot poll system dot out dot println after removing two elements iterator iterator 2 equal to q dot iterator while iterator 2 dot has next system dot out dot println iterator dot next. So when the above program is executed at head of the queue, love at head of the queue, love iterating the queue elements, love tonight study v after removing two elements tonight v. Then another class is hash table class. Java hash table is an implementation of hash table which stores elements in key value pair. It does not allow null key and null values. It is synchronized version of hash map. It extends dictionary class and implements map interface. Declaration of this class is given below. Hash table declaration, public class hash table, extends dictionary, implements map, clonable, serializable. Important points of a hash table class. It contains values based on the key. It contains unique elements. It does not allow null key or value. It is synchronized. The initial default capacity of hash table is 11. In this tutorial, uh, in this um, let us study. We will learn to create hash table, add new elements to it, traverse elements, etc. Hash table constructors are hash table. It creates an empty hash table having the initial default capacity and load factor. Hash table initial capacity. It accepts an integer parameter and creates a hash table that contains a specified initial capacity. Hash table initial capacity float loader load factor. It is used to create a hash table having the specified initial capacity and load factor. Hash table map extends v. It creates a new hash table with the same mappings as the given map. Let us see the example code that creates hash table. Let's take an example to create hash table that takes elements of string and integer type pair. Initially it is empty, so if we print it, it shows empty braces. We will learn how to add elements in next example. So import java.util class demo public static void main creating hash table string integer hash table equal to new hash table string integer system.out.println hash table. So the output is an empty table, empty flower brackets. Then adding elements to hash table. To insert elements into hash table, we use put method that adds new elements. It takes two arguments. First is key and second is value. So the above program is modified as import java.util.star Class demo public static void main string arguments hash table string integer hash table equal to new hash table string integer adding elements hash table dot put string is a and integer is 100 hash table dot put b 200 then c 300 then d 400 is added displaying hash table system dot out dot println hash table then we get b equal to 200 a equal to 100 d equal to 400 c equal to 300. Let us see whether it allows null or not. Since hash table does not allow null key or value, then forcing to insert the null will throw an error. Let us see the example. Import java.util.star class demo public static void main string arguments creating an hash table string integer hash table equal to new hash table string integer hash table dot put an element then at the end hash table dot put null comma 0 error, no null allowed so displaying hash table. So when the above program is executed, since we are trying to add null, it will throw an error. Exception in thread main java.lang null pointer exception.